Oh, I'm muted still. Because I can. Is everybody else thinking I'm muted as well? You're good now? Okay. Carter, try to leave and then join again. There might be an issue with the network. Okay. There we go. So SOHCAHTOA is just to help you remember that sine, when you're using sine, you're involving the opposite side and the hypotenuse. If you're using cosine, we're using adjacent hypotenuse. If you're using tangent, you're using opposite and adjacent. Okay? Try to rejoin. Okay, so that's what we're doing here. And also remember that sine, cosine, tan always need an angle glued to it, be it a letter if you don't know what the angle is, or an actual number if you do know what it is. But you can't just have sine out of nowhere. Okay, and you can also not just, I have some students just say D is equal to 3/5. Not right. It's sine of D is equal to 3/5. Okay, so let's to refresh, I got to make sure you understand that. Let's graph another triangle here. And I will kind of mix it up on you a little bit. Okay, so we're going to call this X, Y, Z. Okay, and we're going to go 0.9, 1.2, and 1.5, like that. And it doesn't matter if it's centimeters, inches, feet, you name it. Okay, so I'm going to mix it up on you here. So be careful. Cosine of Y. Put down the two numbers. Sine of X. We'll put down two numbers. Tan of Y. Put down two numbers. Sine of Y. Put down two numbers. Tan of X. Put down two numbers. What am I missing? Cosine of X. Put down two numbers. I want you to, and it's not a big deal if you get this wrong. Don't use a pen. Use a pencil unless you're very confident. Put down the two numbers that would have to go with each one of these trig ratios. So cosine of, I'll do the first one with you because I know it's a bit of a refresher. Watch carefully. Cosine of Y. What's our reference angle? It's Y. So you place yourself here. What's cosine asking for? Let's see. Cosine is asking for adjacent over hypotenuse. It's very easy if you're here to quickly label opposite. This is the hypotenuse, that doesn't change. And this is the adjacent. Okay, based on this being your reference angle, it's opposite, hypotenuse, adjacent. Go ahead and do all the y's right now because you want to have y as your reference. Fill in the ones that have y as a reference angle. Do that right now. Is there anybody in here that needs a calculator for today? Everybody, if you need one, there's one up by the ledge by the whiteboard there up front. Carter, did you join again? Okay, thank you, Isabella. That's kind of you too. Yeah, gotta help each other. Okay, thank you. Are we done? Okay. So I will do the y's right now. So when you get a mixed bag like that where they mention both angles, do the one angle first. Okay. So cosine of y. Let's do it one more time here. It's easy to do. So ka toa, right? This is cosine of y. Cosine is asking for adjacent that needs to go on top. It matters which one. That's 1.2 over hypotenuse is 1.5. That's what you would have to put in here. You go to tangent of y. Tangent is asking for opposite over adjacent. So based on y being here, opposite is 0.9. Oops, wrong one. This one here, 0.9. And adjacent is 1.2. Okay. Then I'm going to go to sine of y. Sine is asking for opposite. Watch this, right? Opposite and hypotenuse. So opposite based on that is 0.9 and hypotenuse is 1.5. I'm done with all the y's. Now I'm going to switch over to x being my reference angle. So look at where my left finger is here. I'm going to say, okay, now I'm positioned here because they're mentioning this angle. And what changes now? This is now what? This is now opposite. This is now adjacent. So opposite and adjacent are very much dependent on where you are. Okay? So if x is your reference angle, then let's do sine of x here. Opposite over hypotenuse. In this case, opposite is 1.2, hypotenuse is 1.5. Tangent of x, it's asking for opposite and adjacent. Opposite is 1.2, adjacent is 0.9. Normally we don't switch reference angles in a triangle, like we just stick with one. But I need you to understand how it works. Okay? And then cosine of x, it's asking for adjacent over hypotenuse. So based on that, it's 0.9 over 1.5. And there you have it. Okay? So very important for you to understand that right now we're not solving for anything. We're just stating which two sides, which two numbers would go there if we had, if it was asked to do so. Okay? All right, let's keep going. We're going to solve for sides now. Using trigonometric ratios to solve for sides. That's what we're going to do now, okay? And I'm going to tell you the steps. Determine the reference angle. The one you know. Okay? And then the second step is label all sides. in this order: opposite, hypotenuse, adjacent. Third step, cross out don't know, don't care. And you'll know what I mean in a bit. Yes. 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 If that's the case, then let's do that. Okay. Thanks. Cross out the don't know, don't care side. Sorry, I need to add that. Set up and solve. And of course, these steps are just to guide you. They're not necessarily gonna but I would say having this on your study sheet is probably a good idea. Okay. You might have a summarized version of this, but I would definitely say go for it. So example. And this only works with right triangles, folks. If you have a triangle that is bigger and it's split up into two right triangles, then that's what we're doing. Okay, we got to work with one, then the other. Okay. So let's say you're given a triangle like this. This is 35 degrees here. Let's say that this is 7.5 inches, and they're asking for this side right here. That's our first example. So our reference angle, and after a while you'll just know what to do, okay? This right here is our reference angle. Okay, reference angle. Based on that, we're going to label all three sides. So this is the reference, so that means that you're in this corner, and this measurement is literally measuring the opening between these two sides. So this is opposite, hypotenuse, and this must be the adjacent. Okay, so we've done one, we've done second step. Which one is the don't know, don't care side? What does that mean, Mr. Dirksen? It's the, this one you care about, this one you know. This is the don't know, don't care, right? You don't know what it is, and you also don't care. So you cross that out, like I cross this side out. Okay. Now, which one of these three, and only one will work, by the way, you are left with, watch carefully, you're left with H and O. Those are the only two sides that are left. Which one of these three has H and O at the same time? It's this one. Okay. You have H and O is here, so you got to use sign. H and O are left, use sign. So by crossing out one of the sides, you're left with two sides, and then you just go find which one has those two sides. Is it sine, cosine, or tan? In this case, it's sine. So you set it up. Sine of what? Remember, it always needs an angle. We know what the angle is, so we go 35 degrees. They're glued together. Is equal to opposite So opposite is 7.5 over hypotenuse, which is x. That's your setup step. You're setting it up. And what now? This is where you introduce the trick. You go to sine or cosine or tan, right? This will vary. Just put a 1 underneath it, because it doesn't change anything if you do that. And do you remember cross multiplying and dividing, right? You got to cross multiply like this and divide going up, right? To get x, you got to cross multiply and then divide. So write out that step. X is equal to 7.5 times 1 divided by sine of 30. X is equal to, let's go ahead and solve that. If you use a calculator like mine, 7.5 times 1 is just 7.5, right? You're just going to go 7.5 divided by sine of 35. Before I do that, hold on. Sine of 35, folks, is just a number. Watch this. I'm going to clear my screen. You're scared of this, right? It's just a number. Watch. Sine of 35 equals, the calculator knows exactly what that number is. It's 0.57357, right? It keeps going. So when you're doing 7.5 divided by sine of 35, you're actually just dividing 7.5 by a number that will be given to you by sine of 35. And so this is 13.0. We got to watch out. That 5 bumps that 7 to an 8 inches. Done. You're done now. Okay? We're going to do a couple more so you really get into that groove, okay? Make sure at home you're writing this down, okay? Another example. And the more you do these, the fewer steps you will need to show, right? Like it's just going to be second nature after a while. So let's try to draw them, you know, upside down, whatever. Let's say this is 58 degrees. And they're asking for, I want to switch it up a little bit. Let's say this is 23.8 feet. Okay, that's 23.8 feet. And you're asked to find this guy right here. Normally X, but it could be any letter really. Okay. So that's the triangle you have. They're asking you to solve for this side right here. By the way, could you use Pythagorean theorem here? Pythagorean theorem is useless here because you only know one side. You need to know at least two sides. Once you have that second side, you can easily use Pythagorean theorem, no problem. But until then, you can't. Okay, so you've got the opening. You've got this side. So what do we do first? We identify a reference angle. Then we label. You go across, opposite. Across the 90, you have your hypotenuse. This must be the adjacent side. Now you're going to cancel out one of them. Which one are you going to cross out? Don't know and don't care. It's this one right here. You cross out the opposite in this case because you don't know what it is and you're also not asked to find it, so cross it out. Out of the three, so ka, toa, right? Maybe put this on your study sheet so you can just look it up there. This is an H, by the way. Which one has A? So you want to kind of underline just the front, right? The first letter. A and H. OH, no, right? AH, there it is. This one doesn't work either, right? Cross out. So you use cosine. So we got to use this one. So cosine of that angle, remember, they're glued together, is equal to 2 sides. And it's very important that you put them in the right place. This here tells you that adjacent goes on top. So you got to take the adjacent, which is x, you put it on top, and the hypotenuse goes below. That's 23.8. You put the 1 down here. You're going to cross multiply up and divide down. You don't need to divide by 1, but that way you know whenever you see a proportion, that's what you do. Right? So, and I need you to show me the work. 23.8 times cosine of 58. And you might ask yourself, Mr. Dirksen, does it matter if I go cosine of 58 times 23.8? I think it does, because sometimes your calculator, if you type this right next to 58, it will multiply first and then take the cosine, and you don't want that. So I would put down the fixed number, the whole number, and then multiply by cosine of 58. So 23.8 times cosine of 58 is 12.61, and we are in feet. I want to ask you to do something here. 1 second. Is it going to happen? No, it's not going to happen just yet. It's going to happen a little later. But just so you know, this is one of, remember the legs of the triangle? They're still legs, okay? For Pythagorean theorem, these two are still considered our legs. And remember that the hypotenuse is always the longest side. So let's say you do the math and you, very common mistake is to students to flip these, to not put them in the right place. So then it would have been, if let's say you had put this on top, it would have been 23.8 times 1 divided by cosine of 58. And watch what happens when you do that. 23.8 divided by cosine of 58. You got 44.91. Does that make sense? Your hypotenuse is the longest side, but all of a sudden you're calculating and you get 44.91. That does not make sense, right? So you should always check, like, wait a minute, am I doing this right? Does this make sense? Right? So those are mistakes that are happening quite frequently. Okay, next, one more. And sometimes questions do this. You put like a little arc in there. And let's say this is 72 degrees. And this is 17.5 centimeters. And they're asking you to solve for that side right there. And I will give you another one. You know what? You're seeing him always the same way. So I will make him like look a little different, because that throws students off too. So I'm going to make it more like a sliver, you know. And this is 202.5 kilometers. This is 39 degrees. And this is the one you're trying to find. Try those two on your own. See if you can do that. Right? Worst case scenario, you scratch them out. You scratch them out and then you just try again. Okay? Yes. Oh, you had your hand up. Sorry, I didn't see that. How to, well, you always start on the side where your variable is, always. So x is on the right side, right? So if your number is down in the denominator, you'd have to travel across and up. And you always multiply first and divide second, always. Got it? So if this 23.8 had been up here, you would have had to multiply that by 1 going downwards, and then you divide by cosine of 58. Had that case. Make sense? No problem. Oh yeah, sorry. It's a 39. It's a 39. It's a 39. I'm happy with the results so far. Here, at least what I'm seeing here, we're catching on. So let me go over this and then I will ask you to do a bunch on your own, okay? Oh, I let it roll, the recording. Oh well. You can fast forward if you watch this again. All right. So I never did the 90 on this one, but you get it. This is my reference angle, this corner. So going out, opposite, hypotenuse, adjacent. You can just go OAH, it doesn't matter. Out of the three sides, one can be scratched and it's the hypotenuse. You're left with O and A, meaning you have to use tan, right? Like I'm just gonna say this is gonna help me remember how to set it up. So tan of that angle is equal to order matters. O comes first, so that needs to be 17.5. And adjacent next, that's my x. You put the 1 under here. You always start where your variable is, which for trig is always going to be on the right side. You multiply first, divide second, always. That's always how it goes. And that's why I put the 1 here so you know what to do, right? And so x is going to be 17.5 times 1, which is not really necessary, but then you know you're going to have to divide 17.5 by 70, tan of 72, not just 72. And that, based on what I'm seeing, that's the answer. I'm just trusting you. Okay? It's 685 or something like that, which bumps that 8 here to a 9. Okay? All right, keep going. Reference angle is here, O, H, and A. Don't know, don't care, right here. I'm left with O and H, so it's this guy. So I know I'm gonna have to use sine. Sine of 39 is opposite. Opposite is 202.5 over H, which is the x. Okay. You put the 1 down here. You're gonna have to multiply, divide. I'm not going to put the times 1 there anymore. I think by now you get it. This one I forgot what it was, 300 and something. 321.78 kilometers. Make sure you add your units. So 1, 2, 3 lines. That's all I'm asking. But please don't say, some students do this. Don't copy this. This whole thing is equal to 202.5 divided by sine of 39, which equals to 321. Like it's just like a rant. No, you can't do that. That's not accurate, okay? So just put lines down and show one step at a time. Okay. Down the road, right now I'm not going to do that, but technically now that you have two sides, you could find this side here using the Pythagorean theorem, right? But I'm not going to do that today. Today we're just going to focus on trig. So I need you to get your handouts. If you don't have this handout, I'm going to post it right after I'm done explaining. So I want you to, right, homework or what you're doing now is use trig to find lengths. And it looks like this. Can you go find that handout? And never mind when they say to the nearest tenth, we're going to do hundredth, right? 2 decimals. Okay, so go ahead and find this. If you don't have this, there are more here. There are 2 packages that are stapled. Okay, so one looks like that and one looks like that. Some of you just got one individual, like you grabbed one of each, but you should have this if you came through last week. Okay.